Welcome back, guys. For the last few days, I have been exploring LangGraph and Fast API, as you might know. But today, I thought let's work on something interesting, something that I have been planning to do for a lot of days because I have a Raspberry Pi and then webcam running around. I even shot some videos and shared some work I have done. So I thought of completing it because I didn't have the time to sort out the issue that I had with the Raspberry Pi. But when I got time, I thought, okay, let's complete it, sort it out, and complete the video. So last day I updated my system, I updated my Raspberry Imager, and the issue with the Raspberry Pi got sorted. So I thought completing that particular project using building an CCTV AI camera using Raspberry Pi and my PC. So if, as you might know, I share videos related to technology, what I learned, interesting factors that I do per day. So if you're into technology, AI, robotics, or anything related to engineering, and love tutorials as well as doing stuff, subscribe to my channel as well as like this video. So let's get started. So I have named this particular chatbot or CCTV AI bot Watchwise, and you can talk to this CCTV using an LLM. Here we have used LLAMA 3.2, and this is going to be a high overview or a beginner friendly guide. So yeah. So imagine this: you have a guest coming in and people walking around in front of your camera, in front of your house, and you want to monitor to your CCTV camera, and you want to query the CCTV camera using English. And it's going to be not so simple. If you want to interact with the CCTV camera, you might have to monitor each and every step, and that's going to be time consuming. That's where this particular application comes in. You can interact it with using an LLM. You can ask the DB using an LLM, and DB will give you the answer, and you can move on. It's just like talking to a CCTV camera in natural language or using English. So here the involved parts of this particular project are camera, a detector, a DB, as well as a chatbot. So its basic flow is like the camera captures the image, the detector captures what is inside that particular image, and it gets stored in a DB, and the chatbot will interact with this DB and will give you the answer. So that's where the whole flow of this particular CCTV AI chatbot goes in. For this, what I have used is a Raspberry Pi, and inside the Raspberry Pi I have an MJPG streamer, and that particular streamer will send across the videos that gets into the Raspberry Pi into my local system. Inside my local system, I have the DB as well as an YOLO-NAS detector. The YOLO-NAS detector detects the object in the particular frame and will log those detected objects into the DB, and our LLM LLAMA 3.2 will query the DB for the results. So you can ask our LLAMA LLM in natural language itself what is in the box. So it will retrieve that particular information from the DB that is available to us. That's the whole crux of this particular project. So part 1 is basic. We had to get our Raspberry Pi up and running. For that, you can refer a lot of videos that is available here, or you can also refer to the Raspberry Pi official website. There they have given steps to install the RPi images, configure your RPi, install the OS, as well as how to do it even without using a display. Because here I am using just my laptop, not even any other display as well. So for that you have to, and after setting up your Raspberry Pi, you might have to install the MJPG streamer. For that you can just do some sudo apt install MJPG and make it up and running. As you can see, I have already made it up and running, and it is available in the port 8080. So if you want to verify that again, you can log into the HTTP RPi address action stream. Let me see if I have one such instance. See, here is the live video feed of my particular room. So it's readily available over there. Once the RPi is up and running, we have our object detector in our PC. We are using basic YOLO-NAS architecture. I have explained how that works in the previous videos. You can verify that as well. So here I have an env file. In the env file, I have set the path of the model. I have set the video source. I'm even setting the where to log these particular detections to be stored. So these values are stored in my particular env files. You just have to log into the you just have to run the detector.py file. For example, let me see again. I might have set it up and running. Yeah. So here I have set the source as 0. 0 means my laptop's webcam. It should be up and running now. So yeah, you can see me here and there. So there's a small delay there. So the only thing why I choose my PC over the ARPA is the delay, because ARPA is even a low power device compared to my PC, and most probably it will also have a higher delay. Even my PC is having such a delay. So you can hopefully understand how much delay the Raspberry Pi can will have. So that's why we are streaming the video over here, and we are doing the detection on top of the video in my PC. So once the PC detects the object, if the threshold is over a value, like for example 0.85, I'm storing those values into my DB, and I have set up a basic PostgreSQL DB for this particular matter. And you can interact with this PostgreSQL as well. You just have to set up the query. You can just query it. I haven't installed a UI for that. I think dbeaver can help you to interact with this particular Postgres DB as well. So this is the data model I had chosen for this particular purpose. So the table name is object detection. We have columns like ID, timestamp, camera ID, object label, confidence, bounding box, etc. So here, even though we have multiple names, ID is an UUID or even a sequential ID. It just adds on top of each other. For each frame, a new ID is generated. And timestamp is to identify at what moment we got that particular object. For example, you want to identify what object is detected 10 minutes before. So for that, you need to know the timestamp. That's why we are saying the timestamp. Camera ID, even though we are just using single camera right now, there is a provision to improve or increase the number of cameras. So for that, we need a camera ID. That's why we are using a camera ID. Object label is to identify the objects in the frame. And conference, we are using a YOLO detector. So there is a chance when the conference is lower, the YOLO is detecting the particular object wrongly. So to avoid that, we are also storing the confidence level as well. And we have bounding boxes, that is just to identify where this particular object has been identified. After that, that's where the magic happens. We have our LLM pulled and ready to run. You can just query the LLM using your English language. I have set up a basic, a prompt. So you just prompt with this particular LLM, and this particular LLM will retrieve the information and give it back to you like a normal person. So let's see that in action as well. So as you can see, I have already did some queries. Some of them are wrong, some of them are right. So what is being detected? So LLM is supposed to, as you can see, based on the database results, it may appear nothing is being detected. The results only show two objects, person and chair, but they do not indicate what is being detected. So it is retrieving the information from query and returning to you like a normal person will do. So after that, we have our end-to-end flow. Let's try that as well. For example, in the normal flow, we don't have to specify even the source. We can just run it. So this is what you will see. There are some wrong dictations there. Helmet has been dictated as a cat. The clock is being identified recent nice. Couch is being detected as bench. And we can interact with our llama as well. What is being detected? See, cat, bench. Based on the query results, it appears that several objects are being detected in the scene, including a furniture, a person, household items, clock, vase. So As you can see, you can query the particular DB using your LLAMA interface. So this is what our basic application does. So what is the use here? You can interact the whole log, even giving a time period. You don't have to surf over the each time log. You can just ask the query. The query will be answered based on your questions, and that too in natural language without much delay. So this is what we expect from our particular Raspberry Pi CCTV camera. So yeah, for some troubleshooting, we can check if there is a blank feed. I have already shown Raspberry Pi is streaming itself. No logging, verify your DB is being connected. There will be a lag, and that is because our either due to our Raspberry Pi is really low powered or due to network. And yeah, like I said, this is a very simple project. Raspberry Pi. Why have I chosen this flow? Is like Raspberry Pi is a very low power device. It cannot be used to detect objects on a higher rate. So that's why we are streaming the video feed to our PC, and the PC is detecting on top of that particular on top of the frames. And all the heavy lifting is done by a PC. In your case, a server, maybe a better server, a better system, and you can ask, clean and query data using our LLM. In this case, LLAMA 3.2. Since we are using an on-device LLM, your data is safe and secure. You are not sharing it with any other vendors. Your data will be safe with you, and the LLM is in your system, and you are interacting with that LLM, and that LLM is interacting with your data in your system. It's totally your private. Your data is totally secure with you. And LLMs, like I said, the exploration, the interaction becomes quite natural. It becomes quite easy. That's where LLM comes into the picture. So, if you are interested, I will share the GitHub link. Give it a shot. I might have some security issues as well. You can share them as well. You can try and share them as well. You can learn about by doing this project. You can learn about RTPC, then hardware optimizing, model optimizing as well. This is some code snippet that I have used for object detection. This is related to YOLO-NAS. You can verify. I will share the GitHub link. So yeah, so that's it. The video or my work regarding YOLO, using YOLO-NAS to create a CCTV a robot assistant is done. So if you are, like I said, if you are interested in AI, robotics, or even technology, try to follow or subscribe to the channel as well as like this video. Bye.